So without any further ado, I'd like to introduce Hongbo Zhang, who is going to be introducing the MoonBit language, joining us from halfway across the world. Hongbo, take it away.
All right, thank you. So, good morning, everyone. Can you hear me? Just double check. Okay, cool. So, sorry I cannot attend the conference in person, but I wish you enjoy the conference. I'm very excited to share with you about the work we have been doing in the last 2.5 years. It's the MoonBit. It's a new programming language and toolchain, which happens to be designed for the AI area. So yeah, let's go ahead. So before I go to the content, I'm very happy to introduce a bit about myself. So I have been working on the programming language and developed tools for almost like 20 years. Back to my bachelor degree, my first language is the main semester language for the animation. Then my master thesis is also meta programming language, which is a superset of OCaml. So you can use the fan to write a new language. So it's a meta language. Then I was lucky to contribute to OCaml as a contributor in my graduate study, and also in my first job. So I joined Bloomberg. So in my hobby project, I made a barcode script, which later was used by some companies, including the Facebook. So I was very honored to join the Facebook to continue developing the barcode script, or called a script. There I was also contributing to the Facebook flow, which is basically the Facebook TypeScript internally. So I'm very lucky to been working on the programming language for many years. And then that's the way lead to the MoonBit, the best of MoonBit. So today's talk, I'm going to introduce the 3 sections. First, the why MoonBit, our long-term version, and our midterm goals. And then we'll go through the what's MoonBit. So it's a design philosophy for tooling, and a brief overview of the language, and the multiple backend support. And the last part, we'll go through the AI assistant programming. So what I mean by the AI native language? So that's pretty much I want to share with you. So the story of MoonBit actually is a pretty, MoonBit itself is a pretty new language. So back to the October 2 years ago, October 2022. So my former PhD advisor, Harry, he invited me to build a lab to make a completely new language from scratch, and with a team. It's a very exciting opportunity because back to the time when I built the barcode script, it began as a hobby project. So I mostly work on the weekends. So actually for this time, I have the full-time team to work on the whole new language and tool train. So I have to do long-term thinking. So what's the next big thing in the programming? Because the investing in programming language is really a very large investment, and it takes many years to get a mature ecosystem, right? So we have to think in a hard way, what's the next big thing? Also because this is a funded project, so we have to make sure we can deliver the stuff year by year, so we can have some milestone, so we can show we are achieving some progress. Instead, if it's a one-man project, then we can just do it for 5 years, then show the people we have made some progress. But this is not the case. We have to do the incremental delivery. Yeah. So what's the next big thing? So when we studied the MoonBit around 2 years ago, we found one thing which got us excited is cloud computing, especially with the birth of the new extraction set called Wasm. So Wasm is, if you don't know more, Wasm is a new virtual extraction set proposed by the several big companies, including Microsoft, Google, and Apple. So it's cloud platform. It's a lightweight extraction set, and it's more secure and more safe. I think the big opportunity for the new language, because the Wasm is a pretty new instruction set. So for the most established languages were before the birth of the WebAssembly. So it doesn't really translate well to the WebAssembly instruction set. Take Go, for example. They can be compiled to the WebAssembly, but it doesn't deliver the really good performance. So when we say WebAssembly by itself is very lightweight, but if you compare the Go, it's Hello World Go will compile 2 megabytes. So it's not take advantage of the WebSum instruction set. So if we build a new language, so we can do a much better job than the existing solutions. So this gives us the comparative advantage. This is one thing. The other thing is by accident is because when we studied the MoonBit 1 month later, the ChatGPT was announced. So for the first time, we found the AI generate some really practical programs. So it's for the first time we see the AI can do some meaningful stuff in the program synthesis, and it's more and more practical these days. So the open question is, which language and tools are AI friendly? I mean, which languages are more easier for the LM to generate? So one open question is does it make sense if the language itself is easy for static analysis, means it will be easier for the LM to generate code, or should we build IDE optimized for large language model instead of the human programmers? Because in the future, a large portion of program will be written by LM, right? So, and how do we enable concurrent AI-based IDE? Because the AI is pretty much cheap than the human programmer, so we can spawn hundreds of the AI programs pretty easy to get work on large projects. In that case, we need to make sure that they can work concurrently to have a concurrent AI-based IDE instead of the traditional human-based IDE. So these are very exciting opportunity for us. That's our long-term vision, to make the very large-scale AI assistant programming from the ground up. So we want to make the IDE for hundreds of AI programs to collaborate on large projects. And because of AI programming, we believe it will fundamentally re-architecture the entire development tool chain, not just the IDE, but also a lot of other stuff, including the version control system. So it's no longer doesn't make sense to do the file-based diff. You maybe need to do the block, even more granular block-based diff. And we also, because AI is still not perfect, so we also need to make sure human and AI agents can work together fully on the same code base. So our long-term vision is to build AI assisted programming, the tool chain from the ground up. Of course, we have a vision, but we also need to put to reality. So this is what's MoonBit. MoonBit is, in my opinion, is an integrated development platform with a very comprehensive tool chain. So it's not just a program language. So when we study this, we have to make sure we provide all the developed tools in a single box. So instead of so we provide the editing tools, the IDE, the debug tools, the build tools, the testing tools, the coverage, packaging, and AI integration. All the tools you can imagine for the develop. And we also design all the tools from ground up to prioritize the AI productivity and the reliability to reduce the hallucination. And the second point, I think, is we care about the tooling. We prioritize the tooling more than the language feature itself. The third part is the fast feedback loop. We believe in a very near future, the AI agent, its performance will matter because the AI is not perfect. So you want the AI give you the feedback as soon as possible. The fast feedback loop is still very important, in my opinion. So MoonBit is standing on the shoulder of a lot of the existing languages, including the RESTscript, Go, and Rust. So of course, the first one, the RESTscript, have a very large impact on the MoonBit. So the one killer feature of RESTscript is compiling really fast. It's so fast that some people in the community ask if we give up something by compiling as fast. Actually, that's not the case. I think the point of the RESTscript, why it's so fast, is because it does very, very tight vertical integration. So the whole build system, the compiler the library, almost is in the first version was made by me because it just I don't have other people to help me, so I have to build all the stuff by myself. So it's very, very faster than the alternative because everything is no longer a black box. So traditionally, if you build a compiler, right, you don't need to worry about the makefile. It's just you make the build system. But it's not the case for the RESTscript. We optimize all the pipeline for the fast compilation. And I also mentioned in the reply, I'm touring around a new language with a Wasm backend support. and it only took 28 milliseconds to type check the 6 package. Actually, that's the MoonBit. That's the top project I mentioned. Yeah, so this first one. And the second one is Go. I think Go has a very deep influence on MoonBit. So one key philosophy is less is more. We think we don't want to keep adding new features. We want to make sure the language itself is a very simple language for people to understand. But we must focus on tooling. So the main difference between MoonBit and Go is which part is essential in programming. Otherwise, we agree with I think less is more. It makes perfect sense. The other language which influenced MoonBit is Rust. Rust is a very well-designed programming language, and because it's a modern one, so it absorbs a lot of good parts from other programming language. And we believe we take the good parts from the Rust, except the border check, because we think such complexity is not needed for the day-to-day programming. It's only needed for like the bare metal, like the system, very low-level programming, but it's not ready needed for the application development. And the third one, I believe is critical is the programming should be fun. But in my opinion, is I don't find too much fun if I need to fight against the borrow checker. Yeah. So we will mention the long-term vision, but we also need the midterm goals. So we need to do the incremental delivery. We don't want to work on the programming language for 5 years, then still nobody to use it. Actually, and in reality, we get very good result. We get our first commercial users in 2023. It's just 1 year after the language was built. So why? I think it is because we are very focused, and our vision, like making MoonBit focus on WebAssembly, pays off. So MoonBit's WebAssembly backend actually is generate very, very small output size. Because the language by itself is designed to be effective data collaboration. And the WebAssembly backend is the performance is comparable to Rust. And back to the tooling, MoonBit is provided tooling. So the language itself is the co-design with the IDE. This is also one lesson from the RISC. RISC, as I mentioned, RISC is compiling really fast, but it doesn't have very good IDE. So the auto completion, the IDE support is only landed after many years. The language got mature. So for MoonBit, it's different story. We co-design the IDE with the language on day one, and we roll out the LSP service in our initial alpha release, just 1 year after the language got started. And actually, MoonBit is not just have a good IDE. Actually, IDE is pretty unique, in my opinion. So the whole IDE can run in your browser without any server-side container. So you have a full working IDE just in your browser, and it's pretty lightweight. I can show you it's pretty lightweight. So I can go to take this for example. I don't know. Let me check. So I can just So take this for example. You have the whole IDE. You can see the screen, right? You can go to the left side is the IDE, and the right side is just your game program. And then this is full working IDE. You have very fast feedback loop. So here you can just make a very fast auto completion, and you can change the code. For example, I can change the player from 5 to 7. Then if we have an effect, it's too many Mario. So I can say 4, and it has very fast compilation. Yeah, so you have the whole IDE in your browser without any server-side container. The IDE is pretty lightweight and functional. This is a unique point of the MoonBit. So, and we also take lessons from Rust. Rust has the Rust analyzer and the compiler, but they have different code base. For MoonBit, we don't want to develop the two compiler just for the IDE. So the MoonBit share the same code base between the IDE and the compiler. And when we design the language, we make sure the Moon language by itself enables very, very fast static analysis. And we do the parallel type checking and incremental type recovery by design. Every phase in the MoonBit compiler, including lexing, parsing, and type checking, is fault tolerant. So it means if you do the lexing, if you found a bad token, this will still continue. And and it's parallelizable. Even for the lexing, you can lex the MoonBit code pretty much from any line. So yeah, so this enables our MoonBit can be very fast static analyzed. And about tooling, and we care about the testing. This is because we found in the AI area a lot of code will be generated by the AI and a large. So you need to make sure you need to gain the confidence in the generated program. So you need to make sure the testing is easy to write and easy to verify. So we have in built-in testing, the test is a keyword in MoonBit. So in reality is people like to write in test in MoonBit because it's so good. So our community-driven core library actually has the 93% test coverage. I will show you a demo how easy it is to write the test in MoonBit. Yeah, and we also care about the debugging. So we provide our debug support on day one, including the source map debug support when you compile to WebAssembly or compile to JavaScript. And it is GUI based, so you can just click the right point and then go to the debugger. And we are going to release the LDB based debugger this month. So I think in next week we are going to we can more advanced debugger. So let me show you the basic workflow. If you write the code base in MoonBit, how it works. So let me check the code. Okay, so if we go to our external library, here I want to write a new function, right? I need to write our favorite Fibonacci function. So I can just say okay, int, and return an int. And so here I write the function. Now I want to test this one. So I can just write test keyword, and then say Fabi 1 2 3 4 5, and see the result. Yeah, right. So I can. If you see so I can just update the, sorry, here is a typo. I need to cut map. And then update the test, then you get the result. So if I change the programs, I change the semantics a little bit, +1, then just update. Or you can see the value changed. And you can see we have the test, the coveraging. We can just run all the tests in the panel, and we see the coverage in this side. And here we can click the point to debug the program. So I can set the debugging, and we can just debug the testing. See, I can install here. Yeah, I can go inside. I can see the value. Cool. So this is all the whole workflow. The write test is really easy. Debug is also pretty easy. Okay, yes, and the other part is about the exciting part I want to share with you is the documentation-oriented programming. So MoonBit takes the documentation really serious because we think the programmers don't want to write documentation. So we want to make the tool really easy for people to write documents for the MoonBit packages. And the documentation itself is treated as code with type checking and verification. You can just write Markdown files, and the full ID service will be available when you write the Markdown file. Take this slide for example. This slide I show you today is written in Markdown. It by itself is type checked. Let's go, show you the source code of this slide. So I can go to this slide. You can see this slide is a Markdown, but here we have the full ID support. If I make so this codes me, I can format the code. I can also just write I can get all the completion when I write slides. And if I make some typo, it will complain. So the Markdown service will complain. So MoonBit can take the MoonBit.Markdown just as a normal MoonBit program and give you all the ID functionality. And you can even debug. You can even debug the MoonBit program in the Markdown file in the documentation. And then you can render the Markdown into a very beautiful HTML as a blog post. So yeah, so we worked really hard to make the tooling and the documentation easier for programmers. And you can go to, actually, because our whole IDE is in your browser, actually you can go to the our tool, the MoonBit.com, and then you get the interactive learning materials. So here is a interactive, the tutorial for MoonBit language. You can click. There are a lot of tutorials, and it's interactive. If you change the code, for example, I change the value 333, then we have the new value traced. Every value will be traced. So here I just say let x equal +3, right? Everybody. So you don't need to do anything. It will be will be a real-time trace program, and you can debug the program without installing anything. I can open my favorite develop tools. Yeah, I can open my favorite develop tools. Then I can go back to the, oh shit, yeah. I can go back to the, and then debug, click debug. Then here I can just, yeah, here I can step in, debug. So without installing anything, you have a browser-based debug for MoonBit programmers. You can see, I can just step one by one, debugging the MoonBit programs. Okay, let's go back to the, close this one. Okay, cool. So you can go to the website and do the live debugging, live tracing, just in our website. So I show you how much we pay attention to tooling, but language by itself, we also spend a lot of energy to make the language itself a pretty good language. So what's the MoonBit language like? So you can imagine MoonBit is mostly like the Rust with the with a selective good part, we believe. So it has all the essential features with async from Rust, like the trace, enum, pattern matching, and generic programming. Beyond that, we also focus on 1 and 2 paradigms. One is the data-oriented programming and check the effects. So data-oriented programming, it means we really do a lot of work to enhance the pattern matching to make it really easy to process the data stream. Let me show you the example. So here, of course, this is pretty easy to understand. You can just write the enum type, pretty much like Rust. You can just define your enum type, and you can derive the EQ and the shoe. So EQ is a trait, right? EQ is a trait, and shoe is a trait. So you don't need to write the boilerplate code. We can do the automatic derivation for the trace. And beyond that, we provide a very rich pattern match, way more than just an ADT. We provide like, here we have a function called process. Process, the input is a value, which is a JSON type. They can pattern match the JSON in a native style, right? You can pattern match with the JSON, and then we have header and tails. Here we can go inside. Pattern match if it has a name field name, has a string value, and name has a string value b. And then we can use the if as a predicate. Say, oh, if the string itself has a prefix, then we take the rest of part and then compare the rest to b and say, oh, if they're the same, print right and the same name. Otherwise, we'll print the s. So here we have native support for the pattern match over the JSON, and it's not dynamic. It's actually the static. We have provided you with the exhaustion checking, all the good stuff for the pattern matching, and we have pattern matching for the array, from head, from tail, pattern matching for the string, all the even including the prefix, and the pattern matching can be nested and composed with its expression. So you can also pattern match JSON map all the built-in data structures. So here is another cool example I want to show you. Is a palindrome function. For palindrome function, is basically when you read from left to right and right to left, it's the same string, right? Here we can pattern match of the string. Pattern match of the string is when the string is empty or only of a single character, it returns true. Otherwise, if it has more than 2 characters, we can pattern match, get the first character and the last character, and compare them. If they're the same, we continue the rest. So in MoonBit, the continue can take a payload. So you can loop back. You can have continue the rest, which is another string view. Otherwise, return false. So this is always correct. But there are some cool stuff in the pattern match. First, it's a Unicode safe processing. So here, pattern match not just a char code, or it's a Unicode. So the first and char is a Unicode characters. So it's Unicode safe processing, and the whole process is very efficient. So there's no heap allocations because we put a lot of work to make sure there's no heap allocation when for the pattern match of the stream, and it's simple and elegant. So here, because there's no allocation involved, so this code is comparable to the handwritten C style code. Very efficient. Cool. So the pattern is a cool example. Another more advanced stuff is UTF-8 decoding. UTF-8 decoding, here we decode the byte stream to a stream. So first we create a stream builder in the beginning. Then we can pattern match over the byte stream. And then we can say, oh, if the first one is an ASIC character, we can just continue, right? We do some stuff and do the continue. Otherwise, we see the first 2 bytes. We can do some work over the first 2 bytes, then we continue. So we can pattern match over the bytes in a very elegant way and without any allocation. So it's not just elegant, but also very efficient. So yeah, you can see the whole data-oriented paradigm is really cool in MoonBit. Yeah, so beyond that, we have the expression-oriented programming. So the left side is a Python. So we want to find some target from the sequence. The right side is a generic version of MoonBit. Here we have some cool stuff. We do a for loop over the array, Then we compare the value. If the item is equal to target, we break with some payload. Here, so otherwise we return none. So here you see in MoonBit, the for loop actually is an expression. So everything in MoonBit is an expression. Here we can, even for the for loop, it's a purely functional but very efficient for loop. And as I said, for loop in MoonBit actually is a function style. Of course, we support the traditional mutation style. You can just declare the sum as a mutable value, then can do the accumulation. But you can also write in the MoonBit for loop in a purely function style. Here we write the array value, then we declare a for loop has an internal initial 2 states, I equal to 0, something equal to 0. Then we have a predicate. Then we continue with a new state, right? So it's state passing instead of the mutation. So it's purely functional, but very efficient. We compile to exactly as a C program. Then we break with a payload. So MoonBit encourages people to write the efficient function style. And because it's purely functional, we can very easy to analyze. The I is inbound, the array is inbound. Then we can get rid of the bounce tracking in the generated program. Okay, so let's go to another cool stuff I want to show you is a checked effect. What do you mean by checked effect? Effects, there are many effects, including the exception and async, right? Here in MoonBit, if you have the function itself has a exception, so you can just make a bound operator here, which means, oh, this function has some effect. Then we say if y equal to 0, we go to we call the fail function. Otherwise, we return the x by y. So in MoonBit, if we raise an exception, it has to be clearly mapped as a effectful function. So, and we have a static count flow with a checked exception. Then if the function itself, if you make the function as an effectful operation, and there's no error happening, then the compiler will complain, oh, you said it's some function with effect, but there's no effect happening. So here the use case of the exception. Here we have some value in the beginning, then call div function, which means it's an effectful application. Then get the value, and then we can try cache. Here, because everything is static, so the error handling is very fast. So it's just a local go-to. There's no heap allocation, and if there's no error in the try body, then we'll give it a warning. Say, oh, it's unused try blocks. And it's type safe, so you can pattern match over the error if you want. Okay, cool. Another stuff I'll show you is the async. Async is another effect, so you can just add a new effect called async. So here we have GIL. It's async function, and then we have a fetch all, which takes all the URLs and return another array of string. Here, then we can do a for loop, call the effectful function, and get the result, return results. So yeah, we can treat the error effect as an async effect in a uniform way. So the compilation of the async effect is nothing new. So you just compile with the continuations, with the normal and error continuations. This is the same as Kotlin. And the async effect is already shipped in our public release, but it's still experimental in this stage. We're still some design choice to make in the next few months. And we're going to explore more like the stretch concurrency in future release. And because we are going to ship the virtual package support, so we can provide the same async, the public API, but with the underlying, we can have different implementation for different backends using the virtual package. Cool. And another thing I want to show you is the effect polymorphism. It's still work in progress because we can write a very generic code. Here we define a polymorphic effect. So F is a polymorphic effect. So it can be any effect, right? So you can write a very generic code. Then when the map is instantiated, we can say, oh, if it's an array function, then the whole map will have an array effect. If the map is take the async callback, then the whole function will be async. But this has some other complexity stuff. We can, if you are interested, we can discuss more in offline. Cool. So because this just 1 hour conversation, so we cannot cover all the stuff. You can go to our website, visit the MoonBit. It's a native-oriented language and a limited object-oriented style and a function language. Yeah. So we just stop here and go to the next section. Oh yeah, so as we mentioned, MoonBit supports compiling to WebAssembly, which is our first primary target. But we have many targets, not just WebAssembly. Actually, MoonBit supports a lot of targets. One is the WebAssembly, 1 and 2, without garbage collector. And we also support the WebAssembly component model. And besides the WebAssembly backend, we also support the compile to very efficient JavaScript output. And we are also working on the native backends. So we shipped the LVM backend a few months ago. Then we also have the C backend for the native. So these are three main backends we are very focused on. So for the WebAssembly backend, as we show you, is really good for the in the WebAssembly platform. When we initially announced our WebAssembly backend, so in 3 key metrics, MoonBit is doing really well. For the compute time, we are comparable to Rust and way more faster than the Go. And for the WebAssembly size, MoonBit even half the size of the Rust and way smaller than Go language. For comparison, MoonBit is also doing the best. Actually, in the real world scenarios, I believe MoonBit is way more faster than Rust, not just 9 times. It may be like 10 to 100 times faster, compilation faster than Rust. So this is one backend. And for the JavaScript backend, MoonBit generates a quite efficient JavaScript, the handwritten JavaScript. The left side is the traditional JavaScript style iteration. We have a lot of callback, data.flat map, filter, and you have a lot of closure allocated. The right side is essentially the same code in MoonBit, except we have a data.iter. Here, we learn from Rust with the iter. When we go to iter, we will do the simple optimization. We will filter all the callback into a single loop. So you don't really pay for the function training style. MoonBit for this code, we generate 26 times faster than the handwritten JavaScript because we have a super optimized compiler. Cool. So back to the native backends. Native backend is even more sophisticated, but we can compile to C for microcontroller units because for most edge device they will provide a C compiler. This is ideal for embedding and the resource constrained environment. We also support compiling to the LVMIR for the battery optimization and the debug support. So you can just use the LDB as your debugger. And we are in the future, we are going to, actually not in the near future, we are going to write our own Moon SSA compiler framework, which is aimed to be alternative to LVM. So we eventually will go to purely self-hosting in MoonBit itself without relying on a LVM or C. And another thing I think is cool is I believe MoonBit is a language which is ideal for writing compilers. Cool. So MoonBit is a pretty young language. So there are a lot of low-hanging fruit, but the MoonBit performance is already quite excellent. For example, the closures, because MoonBit is a function language, so closure is first class. So in MoonBit, closure actually are heavily optimized away, especially for the hot paths. Most hot paths, the closure will just be optimized inline. And another cool stuff is we do the whole program compilation. This is based on my observation that memory layout is crucial. So instead of the compiler optimization, I think memory layout is crucial. For example, if I have an optional char in MoonBit will be compiled to integer 32. So the none of the optional char will just be a -1, and some char will be just C. So if you have array of optional char, then in MoonBit you have an array of integer. They will be way more efficient than the array of box value, right? So when you do a for loop, that will be way more efficient. But there are some two sides. Because of whole program compilation, we have to do very careful design to make sure we still compile very fast. So here's an example to show you how good the MoonBit is. Here we define some function and a list.t. This is just a function list. Then we define a local mutation value, sum equals 0. Then we call the callback, each callback. And here is the real closure, right? Because the sum this closure will capture the sum. But in MoonBit, we specialize this high order function and then inline. So this will be still no heap allocation at all. It will be as efficient as a handwritten C code in MoonBit. And because this of the high level architecture, actually for our native backend, HTTP is pretty good compared with the Java or Swift. In our initial release, we found MoonBit is really good in the numeric computation. It's much faster than Java, and this is for numeric computation. But for normal payload, MoonBit still beat the Swift and Java in most workloads. This is an amazing result, given the MoonBit is just a 2-year language, but Java and Swift it has been engineered for many years. But I believe the MoonBit still have a lot of things to improve in the future. And I mentioned, because we support the LLVM backend, we can use the LLVM native debugger, which is even better than the source map support. I show you the video. Here we just click the breakpoints, then you can step one by one to go to the debugger. Here, you can go over, get the value, and again you can step one by one. Step in the pattern match. Cool. So you have the actually the LDB based debugger is more precise than the source map, because source map is the only one level name mangling, but LDB is even more accurate. We are going to release the LDB debugger this month. I hope you like it. Cool. We just skip the video. Okay. So let's go to the last part, is the AI integration. This is our long-term vision, but let me show you some work we have done. So AI native programming language actually is nothing new. I think as the creator of the Copilot, he asked, very surprised coding hasn't led to a new programming language or new computation paradigm. And someone mentioned MoonBit in the reply. I think there are already a lot of people working on the AI native language. It's just because the life cycle of the programming language is too long, so it still has some work to do. So in MoonBit, we mainly work on two parts. One is try to reduce the hallucination of the AI generated code. Try to use the type system and starting analysis to guide the AI code generation, and then include the reliability. The other one is we want to support the concurrency. We want to ask the AI agents to generate the program in concurrency and then compose them together for big programmers. And we believe this give you, instead of 20% efficient improvement, it will give you like 10 times more efficient in AI programmer. So the first part is we are trying to reduce the hallucination is the constant decoding. We use the language grammar, formal grammar, and type system to guide the AI code generation. And this will help significantly reduce the errors and improve the reliability. For example, we have two kinds of resampling, local resampling and global resampling. Here is because when you do the LM decoding, eventually in the last stage, the LM will give you many tokens and give you a probability of each token, right? Here we see a lot of candidates. And the first two is XY, which has higher probability, but it's not a meaningful program. It's a syntax error. So we know the first two doesn't make sense. So we can do the resampling to make sure the pub FN is picked. then you get a grammatically correct programmers. This is called a local resampling. There's even more advanced called global resampling. Global resampling is you have the type definition of point. This may be lived in your dependency or in a dependency of a dependency. Here the LM doesn't even see the program of point. But here we have a partial program called sum, which has a value of p of type point. Then you have three candidates, p.x, p.y, and p.co. And we know from static analysis, the first two, it doesn't make sense because it's not a meaningful program. So we can do the resampling to make sure code is picked up. So you see the idea looks simple, but really needs a very hard engineering because the token is empty in a single digit millisecond, right? LM generate token very fast. In 1 millisecond, it may be generate token. So the static analysis needs to go really fast to catch up with the LM token. So you have to do a lot of work to make sure the static analysis is fast enough to not slow down the code generation. This is the first part of work we have been doing. The other is the concurrent ID service. So the MoonBit language itself is designed in a block style. So the program can be divided into a very small blocks, and the block can be rearranged and jacked from different places. So then you can split the package into a lot of small blocks. So for each block, you provide the isolation and coordination. So here for each block, you split them together, and then for each block you generate the code and verify the test. And then if the test pass, you get the result back and compose the AI generated programs. So we provide the virtualization from the language tool train level. So instead, there are people working on the AI code generation. They use a Docker to provide such a virtualization. This is really much more heavyweight than our solution because we just provide the virtualization layer from the language tool train. So you don't need to, you get the compiler will give you a virtualization API to isolate the test and give you correct the type checking result for each AI generated program. Another thing we are working on is to give the AI the compressed context because the large language model doesn't have the enough window size, so you have to make sure the context is compact. So for each package, we provide a formal package interface. Then this will be highly compressed, but it provides a meaningful documentation. So we can provide a very compressed context using the MPT-5 file, give to the large language model. Cool. Yes, that's pretty much the thing we have been working on. I show you one demo we have working on. Here we have some like the warning, 4 warnings. If you are using the Copilot, then you have to fix the warning one by one. We can just fix all the warnings together in a parallel style. Here we generate for each warning, we generate the patch, and then verify it's correct. Then we insert back. All the warnings are fixed in a single click. The other is the documentation. You can instead of document the package one by one, you can document all the functions in this package, and then verify that it's correct. Then we insert the documentation back. Cool. And then you can verify actually it makes sense. It works. And the last one is coverage. Here you want to increase the test coverage. You can ask we spawn the 60 agents in concurrent and provide the virtualization for each agent and verify the generic program if it's correct. We can just match back the result, and then we match them all the tests together, and then we see the coverage actually is increased a lot. Yeah, so this is still, I think this is still early days, but there's a huge potential in the future to make the MoonBit agent more flexible and more efficient in generating the program. Cool. So MoonBit is still a pretty young language and a platform. We are working really hard and moving really fast. So the MoonBit project started 2.5 years ago with 1 people, just me, and we hire a very young and talented team. And I'm really grateful we have a very young talent team. And then we just after 1 year, we made our initial alpha release announcement. And last March, we open sourced our core library with the standard library. Then last July, we open sourced the build tools. And last December, we open sourced the compiler. And in this March, we released our LVM backend. I expect by the end of this year, we are going to enter into a beta release, which means the syntax of language language by itself will be large, unchanged, and stable. Then there may be some changing parts in the standard library, but the language by itself will be in a good shape. So yes, so this is our timeline. And sorry, I cannot attend the conference in person, but we have one people from the MoonBit team, Zhang, actually is in the conference. So if you are interested in MoonBit, you're very welcome to talk with the Zhang on site about MoonBit. Actually, at this stage, we already have a package manager called mooncase.io, and we actually have quite a lot of packages I think around 2,000 packages in our registry. It's still early days, but we have some packages, and we have try their MoonBit.com, which has a full-blown IDE. Just you don't need to install anything, but you try MoonBit. Yeah, and then we have our Discord. You're welcome to join Discord, ask more questions on MoonBit, and we have our SCon. So cool. I think I'm close to running out of time. So that's pretty much I want to share with you about MoonBit. I think it's pretty crushed. It's a very dense lecture, and I'm happy to answer any questions if you have anything about MoonBit. Yeah.
All right. Well, thank you very much. This was an excellent development effort. Everyone give a round of applause.
So if you have any questions, I'm very happy to answer or yeah.
And we do have time for questions. So the way this is going to work is that there will be a microphone passed around to whoever has questions, and then I'll probably repeat the questions so that our speaker can hear them. Are there any questions? One in the back.
Thank you for the presentation. One of the interesting insights or observation you made was that to collaborate with AI on a code base, your version control system needs to explicitly support that. Did you folks make any progress on that? What it looks like? Can you tell a few more words about that, please?
So Hongbo, the question was concerning AI integration and the effects on version control. Did you hear the question?
Oh yeah, I mean the question is about the AI integration on the version control. Oh yeah, so this also, but we are still in the pretty early days. I think in the future the AI will generate a diff in a block-based instead of file-based. So for each block, we have a unique UUID to tag the block. So each AI will work on a single block. Then the diff will be for people to review. Will just be a small block diff. So then you can it's easy to review in my opinion, that's the future. So instead of the file-based diff, it will be a small function-level diff. Then that's my vision for the future, the version control system. Does it answer your question?
Thank you. Any other questions? There's a lot of material in this talk. We have one over here.
This is a very simple question, but can you link from one piece of documentation to another? I found being able to reuse pieces of documentation or refer to each other is very useful.
Would you mind repeat? I cannot hear clearly.
So the question was regarding linking between documentation. You have an automated documentation feature. How do you handle linking between documentation?
Can you repeat again? Sorry.
Perhaps Ian, do you have an example of what you mean?
Yeah, an example might be you might have a definition of something, like the definition of an algorithm, and you might want to link to it from different, different pieces of docs.
Okay, so
a glossary style.
So an example was a glossary. If in a glossary you have certain concepts and they're linking to many, many places in the code, can that be automatically generated? Or is that relevant to your documentation system?
Oh, my documentation is so my documentation. Actually, I can show you our documentation system is code. Let me show you the code. So our documentation, we want because the program don't enjoy writing documents, right? But the program are very happy to write Markdown. So we give you the Markdown for the LSP service in MoonBit. So you can just write Markdown and then call the mbt.md, then the whole IDE when you hover over, you have a whole IDE service, then people will be happy to write a Markdown-based documentation. And then the Markdown-based documentation will be type-checked. So this, of course, AI can generate the Markdown-based documentation, but I didn't try any experiment yet. But in the future, we will give a try. So let's just write the comments and ask the AI to generate the type-checked Markdown files. But we didn't try it yet.
Hongbo's on Discord. You should probably ask him that question there as well.
Okay, let me check the Discord.
Are there any other questions we have for our speaker? We do have a couple more minutes.
I saw one question. How do I join Discord server for me? We have a Discord. But let me check out the link. I will show you we do have Discord, but I don't have a link. But I will show you later to Cool. All right. So, I can take any question, or can guys just?
We've got one more question, I think, and then we'll wrap it up.
Someone is already posting a MoonBit Discord link. Yeah.
What's the state of the UI components, specifically HTML components, and maybe integration with existing frameworks, or how easy is it to build out UI at this point?
Okay, cool.
So how easy is it to build out UI in MoonBit?
Actually, we announced our UI framework, I think 1 month ago. It's Rapid T. It's based on the Elm architecture. Let me show you the, So it's we'll take the Elm architecture and apply it to MoonBit. So you can just write the Elm style UI in MoonBit. In the future, if it's a big thing, we may provide some XML, the JSX syntax, if it is really needed. But we are still evaluating this kind of paradigm. So we already have some UI libraries in MoonBit. This actually is in the JavaScript backend, so it can become. And our package manager, Mooncase.io, is using the Elm architecture to build the UI.
All right, and with that, thank you very much. Another round of applause.
Thank you. Have a good day.